Welcome to Chemsphere Hub. Today's presentation is about the working principle of a UV spectrophotometer. UV spectrometer is one of the most widely used analytical tools in chemistry, pharmaceuticals, biochemistry, nanotechnology, and environmental sciences. In this section, we will deeply explore the principle, instrumentation, theory, laws, and applications that make UV spectrophotometry an essential analytical tool. UV visible spectroscopy studies how molecules absorb UV and visible light. This absorption is directly related to electronic transitions within molecules. The basic purpose is to measure absorbance and determine the concentration or identity of a compound. Basics of electromagnetic radiation includes different wavelengths such as UV, visible, IR, microwaves. UV visible spectroscopy uses UV light from 200 to 400 nanometer range and visible light from 400 to 800 nanometer. The energy of radiation is inversely proportional to wavelength. High energy UV radiation can excite electrons from ground to excited state. In the UV region, we typically analyze molecules containing chromophores. In the visible region, colored compounds are studied. This is visible region whose range is from 400 to 800 nanometer, and it is UV region whose range is from 200 to 400 nanometer. And in the visible region, colored compounds are studied. However, in UV region, we analyze molecules containing chromophores. The lambda max of a substance indicates where maximum absorption occurs. There are several electronic transitions such as pi to pi star transitions, n to pi star transitions, sigma to sigma star, pi star transitions. Pi to pi star transitions, they mostly occur in conjugated system. N to pi star transitions, they occur in non-bonding to anti-bonding systems. And sigma to sigma star transitions, they are high energy transitions rarely observed in UV visible. Absorption occurs when the photon energy matches the energy gap between electronic levels. As we can see that it is N to pi star transitions, it is pi to pi star transitions, and n to sigma star transitions, and sigma to sigma star transitions. These are bonding molecular orbitals, sigma and pi star. These are anti-bonding molecular orbitals, and this is non-bonding molecular orbital. Now we will discuss the Beer-Lambert law, which is directly related to the concentration. If the concentration increases, then the absorbance also increases. So it has linear relationship with the absorbance, and as absorbance is equal to epsilon into path length into concentration. So if absorbance increases, then the concentration is related with the absorbance. If the concentration of a sample is increased, then the absorbance will be increased. In this case, the absorbance is the amount that is absorbed by the sample, and if the absorbance is increased, then the concentration is increased, as we can see from this equation. A is equal to epsilon into path length into C, where A is absorbance, L is path length, and C is concentration. So as concentration increases, absorbance increases. It has linear relationship. Absorbance is also related to the transmittance. Higher concentration results in higher absorbance. This relationship is used for calibration curves and concentration calculations. This is the instrumentation of UV spectrophotometer, where is the light source, wavelength selector, sample, cuvette, detector, and final computer for signal processing and output. Now we will discuss these all parts of instrument in detail. UV spectrophotometer consists of light source, the light source is it has different types of lamps, as deuterium lamps, which which is used for UV region, and tungsten lamp used for visible region. Deuterium lamp has visible region from 200 to 400 nanometer and visible region from 400 to 800 nanometer. These provide stable and continuous radiation. The monochromator separates polychromatic light into individual wavelengths using mirrors, lens, and diffraction grating. It ensures that only selected wavelength reaches the sample. Diffraction grating consists of thousands of closely related spaced lines. When light hits it, it diffracts into separate wavelengths. Turning the grating allows wavelength scanning. So wavelength is scanned while passing through the diffraction grating. Uh, Sample holder or cuvettes, these are also termed as cuvettes. Cuvettes can be made up of different materials, and it depends upon the sample, nature of sample to be analyzed. Cuvettes are made of quartz. If we use the UV radiation, and it can be made of glass for visible radiation. Quartz is essential because normal glass absorbs UV light, and path length is usually 1 centimeter. There are different types of detectors that can be used. The detector converts light intensity into an electrical signal. There are two major types, like photomultiplied tube, which have high sensitivity, and photodiode array. They have fast scanning. The signal is then processed into absorbance. Now we will discuss the signal processing unit. This unit amplifies and converts the signal into a readable absorbance data. As when the experiment is going, then the light is used where that is absorbed, and now signal processing unit that will convert into absorbance data. So modern spectrophotometer use microprocessor for automatic calculations. There are different type of spectrometer, in which one is double beam spectrophotometer and other is single beam spectrophotometer. In double beam spectrophotometer, light separates into two parts. One goes through the sample and the other goes through the reference. This design corrects for lamp fluctuation and improves accuracy. It is more accurate as the double beam instrument because the two beams pass through the sample and reference at the same time, so it can be more accurate. And the other one is single beam spectrophotometer. Single beam spectrophotometer send light only through the sample at one time, and they send light to the reference cell at the other time. So these require manual blanking and are less stable but cheaper and commonly used. The double beam instrument give more accurate results. The general flow is light that goes into monochromator, then into wavelength selector and into sample, then detector and processor. Each component ensures accurate wavelength selection and absorbance measurement. We can see that first light source is present that emits UV visible radiation, then monochromator selects a specific wavelength, then light passes through the sample where molecules absorb light based on the electronic transitions. The remaining light reaches the detector. Detector converts it into a signal. Processor calculates absorbance. When molecules absorb UV light, electrons move from ground to excited state. The energy absorbed is characteristic of the chromophore. This forms the basis for qualitative and quantitative analysis. Lambda max is source that is essential for accuracy. It is the wavelength where the compound absorbs maximum light, giving best sensitivity and precision. We can find out the lambda max by analyzing the sample by passing through them at different wavelengths, and where the high absorbance takes place, that is the lambda max. So that wavelength at which the maximum absorbance takes place, that is called as lambda max. During scanning, the grating rotates automatically and records absorbance at each wavelength. This results in a complete absorption spectrum. Now, what is calibration? Calibration is very necessary. It ensures accurate measurement. Typically, potassium dichromator stands for are used for certified reference material. Calibration is performed to give the to ensure that the instrument is working accurately. As uh, we find out the results of known samples standards which are of known concentration. When known concentration is find out, so we can see that whether the instrument is working properly. So standards are used to ensure that accurate measurement is performed. So um, if we pass the sample of known measurement, the result will be known, and if result will be have some error, then it will be detected that instrument is working not properly. Baseline correction removes background absorbance. A blank or solvent is used to set baseline at zero absorbance. So the instrument is settled at zero absorbance. It is adjusted before experimenting so that the baseline is set and there will be no chance for error and accuracy is increased. Stray light comes from unwanted wavelength entering the system. It reduces accuracy, especially at high absorbance. High quality monochromator are used that reduce the stray light. So stray light error can be removed by using the high quality monochromator. As we know that monochromator converts the light into a single wavelength. So if there is stray light error present, that a high quality monochromator can be used that reduce the stray light error. Noise comes from electrical fluctuations. Drift happens when lamp intensity changes over time. Double beam instrument minimize drift. As double beam instrument gives more accurate result as compared to single beam instrument. We can now discuss the resolution, sensitivity and bandwidth. Spectral bandwidth determines how pure the wavelength is. Smaller bandwidth results in higher resolution. So sensitivity depends on detector efficiency and lamp stability. Sensitivity of an instrument is that how much less amount can be measured by an instrument. So sensitivity depends on detector efficiency and lamp stability. Um, UV visible spectroscopy is used in a number of fields, in number of scientific fields. In chemistry, it can be used in organic chemistry, in inorganic chemistry, and different analytical studies. UV visible spectrophotometry can be used in the study of different compounds during research work and during analysis. If we want to use qualitative analysis, then it can be used. Identification of chromophores and electronic transitions help determine the functional group. So they can be used to detect which identify the compound, that which compounds are present. For example, if we want to know the compounds in a plant, then phytochemicals can be studied by using the lambda max. So if we adjust the lambda max, then we can find out the concentration. Yes, qualitative analysis can be carried out as well as the quantitative analysis can be carried out. Absorbance is proportional to the concentration. Calibration curves enable concentration to determine the unknown sample. As we already discussed that the concentration can be found out by measuring the absorbance through the Beer's-Lambert law. It was discussed in Beer's-Lambert law that quantity can be found out. So, UV visible spectrophotometer is an advanced technique to find out the quantity or concentration of an unknown sample. It can also be useful during the kinetic studies of a chemical reaction, as reaction rates can be monitored by measuring absorbance changes with time. So kinetics can be studied of a sample. It can be used in pharmaceutical applications as it is used in drug assay, impurity profiling, dissolution testing and quality control. It can be also useful in environmental applications such as pollutants like nitrates, phosphates, dyes and heavy metals are quantified using UV visible spectroscopy. UV visible spectroscopy can also be used to characterize the nanomaterials. UV visible determines band gap, plasmonic resonance and nanoparticle formation through absorbance peaks. Industries use UV visible for batch purity, stability studies and concentration validation. Advantages of UV spectrophotometer include high accuracy, fast results, simple sample preparation, low cost and non-destructive analysis. It has also some limitations that include it is not useful for all compounds. Interference can be produced from turbidity. It can have low sensitivity for complex mixtures. To ensure accuracy, there are different ways so that the accurate measurement can be performed. To ensure accuracy, cuvettes should be cleaned. There should be no bubbles in the sample. Avoid fingerprints, as if there will be fingerprints that on the cuvette, then the results will not be accurate. Use correct solvent. Ensure calibration. As we already discussed that if calibration is performed, that it can be checked that instrument is working properly or not. So calibration is an important parameter to ensure accuracy. Common issues include noisy spectrum, wrong baseline, dirty cuvettes or concentration outside the linear range. So proper maintenance solve these parameters. So troubleshooting problems can be solved. So we reviewed UV visible spectrophotometer and Beers-Lambert law, instrumentation, working steps, error, precautions and applications. We can take the example if we want to check the phytochemical profile of a plant, medicinal plant, then we can prepare the sample by the method and then we can analyze the sample in the instrument. We can find out the lambda max, and first if we find out lambda max by checking it at different wavelengths and where the maximum absorbance of a sample takes place, that will be the lambda max. If lambda max we measure the lambda max, then we can adjust the spectrophotometer at lambda max and then we can easily find out the concentration of an unknown sample. As we reviewed UV visible principle, Beers-Lambert law, instrumentation, working steps, errors, precautions and applications. UV visible spectrophotometry remains one of the most powerful, reliable and versatile tools for chemical and biological analysis. Thank you.